Have you ever seen this bizarre equation before? 1 minus 1 plus 1 minus 1 plus 1 minus 1, continuing forever, equals 1 half. It looks impossible, right? How can an alternating sum of ones and negative ones magically equal 1 half? Well, today, using the virtual number system, I'm going to prove this rigorously, step by step. This proof is not just a clever trick, but a deep insight into how logarithms behave in this new system I developed. Let's dive in. Chapter 1, the foundation, virtual numbers. In the virtual number system, we define logarithms of negative numbers differently from traditional mathematics. Instead of imaginary numbers, we introduce a new constant. The natural logarithm of negative 1 equals j. This j behaves under logarithms in a unique way. Now, let's take a simple equation, x squared equals negative 1. Taking the natural logarithm on both sides, we get the natural logarithm of x squared equals the natural logarithm of negative 1. Using logarithm properties, we can rewrite this as 2 times the natural logarithm of x equals j. This equation is the key to our proof. Chapter 2, the recursive relationship. Rearranging this equation, we get the natural logarithm of x equals j minus the natural logarithm of x. But here's where things get interesting. This is a recursive equation. Let's keep substituting it into itself. The natural logarithm of x equals j minus, in parentheses, j minus the natural logarithm of x. Expanding further, the natural logarithm of x equals j minus j plus the natural logarithm of x. The natural logarithm of x equals j minus j plus j minus the natural logarithm of x. The natural logarithm of x equals j minus j plus j minus j plus the natural logarithm of x. And if we continue this forever, we get the natural logarithm of x equals j minus j plus j minus j plus j minus j, continuing indefinitely. Recognize this pattern? It's the infamous alternating series, 1 minus 1 plus 1 minus 1 plus 1 minus 1, continuing forever. Now let's take the antilogarithm of both sides. Chapter 3, taking the exponential exponentiating both sides with base e, we get e raised to the power of the natural logarithm of x equals e raised to the power of j times, in parentheses, 1 minus 1 plus 1 minus 1, continuing indefinitely. Since e raised to the power of the natural logarithm of x simplifies to x, we get x equals e raised to the power of j times, in parentheses, 1 minus 1 plus 1 minus 1, continuing indefinitely. But in the virtual number system, we already know the square root of negative 1 equals e raised to the power of j divided by 2. Since x is also defined as the square root of negative 1, we equate e raised to the power of j times, in parentheses, 1 minus 1 plus 1 minus 1, continuing indefinitely, equals e raised to the power of j divided by 2. Taking the natural logarithm again, we get j times, in parentheses, 1 minus 1 plus 1 minus 1, continuing indefinitely, equals j divided by 2. Dividing by j, which is valid in our system, we get 1 minus 1 plus 1 minus 1, continuing indefinitely, equals 1 half. And just like that, proven. This proof isn't just some mathematical curiosity. It challenges how we think about alternating series, recursion, and logarithmic properties. The virtual number system opens the door to a new way of handling logarithms of negative numbers, without imaginary numbers. If you found this mind-blowing, hit that like button and subscribe for more deep mathematical insights. And let me know in the comments, do you believe this proof holds in traditional math?